Welcome everyone to the part 3rd of Java day 14th session. Today we're going to talk about something called as Java collections. Guys, no interview in Java gets completed without questions on this topic. So it's my humble request that you pay a very close attention to whatever I'm going to explain today. Alright, so with this, let's start with the very first topic in Java collections, and that's about an array list. Because in the previous sessions, we talked about the concept of an array. So basically, we can create an array for any data type available, like string, like integer, for any user-defined type. So you can create an array of any data type. For example, if I ask you to create an array of type string, then this is what you are going to do. So here you are going to specify its capacity. So whenever you are going to insert elements, string objects in this string array object, you can store at the max up to this limit. You cannot store elements in this string array beyond this limit. So this is mandatory. You have to specify the limit in the beginning itself before you store any element in this string array object. In the similar ways, if you want to create an array for a type integer, then this is what you do. So here also you have to specify its capacity. Means you cannot store elements, integer objects in this integer array beyond this capacity. Now what in real project, if you face a trouble that you don't know how many elements you have to store in the integer array or string array or any other array of any type, you don't know how many elements you actually want to store. In that case, it's very natural problem that you will not be able to figure out this capacity in the beginning itself. So you need some concept which can allow you to make use of an array of any type where you are not required to specify its capacity in the beginning. It should allow you to store as many elements as you want, as many elements of that type of array as you want. So if such a concept available in Java, well, the answer is yes. So you have to use a concept known as an array list in order to achieve that. So we have just looked at the point why we are actually studying array list. We are studying array list just for one simple reason, that we make use of an array, sometimes string, sometimes integer, sometimes user-defined array. Now in all those arrays what we create, the problem is the capacity. We have to know the capacity before we can actually make use of the array of that specific type. Now we don't want that to happen. We want something which can allow us to use an array of specific type without specifying its capacity in the beginning. It should allow us as many elements as we can, as we want to store in that. So that is allowed using ArrayList. So that's the reason why we are actually studying ArrayList. Why ArrayList? Because we want to get rid of capacity problem in array. That's all about it. Now, how you create an array? Just by doing things like this. Right? So this is how you create an array. What is the way to create an array list? This is the way to create an array list. You write array list, then you specify the type. For that you want to create an array list, for example string, integer, or any of the user defined type, and then name of that object, then new, and then array list, and then again that same type. Important point what you have to understand is array list you can always create only for non-primitive types. You are not allowed to create an array list for primitive types. So that's the condition here to use an array list. So let me very quickly show you how you can make use of an array list. So if I ask you to create an array list for string, what exactly you are going to do? You're simply going to follow this syntax. Array list string, because we want to create an array list for string. Name of the array list string object, array list. Again, you have to specify the type, and that's it. Now it's giving you the red color, means error. Why? Because it needs its imports to be included on top of the Java file, and for that let me press Ctrl Shift and O. I'm done. So here it has imported the required package on top of the Java file for ArrayList. Great. Now in the similar ways, I can go on creating ArrayList for the type integer. Or for any other user defined data type. Yeah, so the way I've created an array list for string, for integer, you may go on creating an array list for long, for byte, for short, for boolean, or any other non-primitive data type, including user defined type. For example, if I here create an object, if I create a user defined type, say country, so I'm also allowed to create here an array list of type country, right? So let me very quickly show you this as well. Public int population. Let me include two fields in this public string name of the country, and then a constructor. Here let me allow it to expect two arguments, population as well as the name. And here let me set the values of population and name, these one like this. Population equals to p, this dot name equals to name. Let me use n. Cool. So our user defined type country is ready now. I know that you are able to understand every bit of this user defined type, right? You know what is the meaning of this and what exactly I'm doing, because we have been doing this all through previous sessions. All right, so now we have the type country available in this project. User defined type means the type which developer has created on his or her own. Now how to create an array list for this? Well, this is the way. Array list, specify country, array for country I've created, array list country. So here I'm done with creating an array list for a user defined type, and that is the country. So it's very easy. The point that you have to understand is when you create an array list for string, or you create an array list for integer, or an array list for country, or any other type, any other non-primitive type, basically it's going to create an array internally for that specific type. For example, in this line we are saying, hey Java, please create an array list for type string. Now behind the scenes, what it's actually doing, it's actually has created an array of type string. Behind the scenes, it has actually used such a statement internally. The only difference is when we use an array of type string, we have to specify capacity. But here when we use array list of string type, we are not required to specify the capacity. It's going to allow us to store as many string objects as we want in it without any restriction on the size. So that's the only advantage. Point which you have to understand is, in case of an array list, internally it actually works on the principle of arrays only. Alright, so now let me show you how you can add elements to it, and you can perform various functions, various operations on this array list object. For example, here for string, what you were doing, you were storing elements, you were retrieving elements, a lot of operations you can perform. In the same manner, what all operations we can perform in ArrayList? Let's very quickly check that. So the very first thing what we have to understand is how to store elements in this ArrayList. So the way to do that is write string ArrayList object dot and make a call to its add function. As this is an ArrayList created for string objects, so it's going to allow you to store only string objects. So here you are going to store string object in that. Let me add Ankush string object here. In the similar manner, we can go on adding other string objects in it, and as such there is no restriction on the capacity, so I'm allowed to store as many string objects as I want. That could be 1, that could be 2, that could be 100, thousands, lakhs, crores, or whatever number. Alright, so let's say I've stored here Ankush, Gaurav, gone to, and then say software. Alright, let's say I've added here how many elements? 4 elements. So Ankush I've stored at 0 index of this ArrayList string object. Gaurav I've stored at first index. Gone to I've stored at second index, and software I've stored at third index. So in total I've stored 4 string elements in this ArrayList object. Important point again, let me reiterate. If you have created an ArrayList for string, then it's going to allow you to only store string. If you try to store say integer in this, then that is not allowed. It's going to cry. It's going to give you red color. It says that you have created an ArrayList of type string and you are trying to store integer, which is not allowed. So this is what you have to understand. Now the way we have added string objects in case of string ArrayList, same way we can go on adding elements in this integer array or country array. Let me very quickly do that as well. Dot add, it's going to expect that you are going to provide integer objects to it. Let me store a value 10, and then let me store few more values to that. Let's say here I store 1000, and here I store 200, and here I store say 1. Alright, in the similar manner, let us add elements to this array country object, ArrayList country object as well. So it's going to expect that you are going to provide country object to it, as this is what you have created for country object. New country. So you are going to make a call to its 2 arguments constructor. You have to pass population as well as name. So here let's pass population as 10 and name as India. Well, I know population of India is not 10, yeah, so don't laugh here, because I know population of India is actually huge. So here let's add few more elements to it, country objects to it. Let's say America. Well, America's population is I believe lesser than India. I don't know. Let's keep its value as say 7. Then let's say one more country object, Bangladesh. Let's say its population is 4, and then one more element, say Russia. China. Well, I know China's population is more than India's population, so let me give it a value 12. So here what we have done, we have created an array list for the type string, for the type integer, for the type country. The way I have created an array list for any of these types, you are allowed to create an array list for any of the non-primitive types. Could be long with L capital, yes, Boolean, or any other type, whatever I showed you in the previous session. Alright, now this is the way how you can store elements of that specific type in an array list. for what you created an array list for. Now, what you have to do in order to display what all elements you have included in an array list of a specific type. For example, here in this array list of type string, we have added these 4 elements. Now, what if I want to display all of these elements? What is the way to do that? The way to do that is again very simple. What we have to do is we have to write the object string array list object, and then we have to make a call to its iterator function. This function is available in ArrayList. So what it's going to give you, it's going to give you an iterator object, string iterator object, which will help you to basically retrieve all the elements what you have stored in this ArrayList object. Here also you have to specify the type. I have to press Ctrl Shift O in order to get the import for this iterator. So here I've got the iterator, the import corresponding to this iterator. Alright, now why we have actually made a call to iterator, and what is this iterator? Well, this is simply an object which is going to be provided here, which is going to allow you to iterate through the elements of this particular array list. And how you can make use of that? You have to use while loop in order to do that. In this while loop, what you have to write? You have to write this has next, and then string a equals to dot next, and that's all about it. Alright, let me explain what exactly I've done here. This is the iterator object, iterator string object, what you have received. And what is this object for? This object is to retrieve all the values of this array list. This is its purpose. Now, how to make use of this object? You have to write while loop, a very simple while loop, and inside it what you have to write, this has next. You have to make a call to has next function of this, and then next function of it. So whenever you make a call to next function of it, it's going to retrieve the string object what you have stored here, and it's going to iterate through this while loop, and is going to give you first this Ankush object, then Gaurav object, then Gontu object, then software object, and every time you receive an object you are actually printing the value for the same. Let me show you this running, and then I'll explain more about the working of this iterator. Alright, here it is. So you stored all the elements in it, and then it got you the iterator object. Then using iterator object you simply retrieved the elements. If you notice here, iterator has retrieved all the elements what you stored in ArrayList in the order you actually stored in that. For example, you stored Ankush first, then Gaurav second, then Gontu third, then software fourth, right? So here also it retrieved all the objects from this array list in the same order. First Ankush, then Gaurav, then Gontu, then software. Now let's try to understand how this iterator works. Okay. So how this iterator works? Let's say this is the RAM. And as I said, when you use array list of any specific type, say here string, then internally it's actually consider this as an array of type string only. So this is how it works. So this is the RAM, and these are the partitions in that. Alright. So whenever you say that you have included Ankush, Gaurav, Gontu, software, this is how it's going to store. First Ankush, then Gaurav, then Gontu, and then software. Point you have to understand it, it's going to store all of these in this way, in contiguous manner. Means If it's storing Ankush here, then it's going to store Gaurav to the next memory of Ankush, whatever is available. It's going to store next element next to this memory. It's going to store next element next to this. It's going to be stored in a contiguous manner. So this is how it works basically. Now when you get the ArrayList iterator object, this is nothing but a pointer object. What it does, as soon as you get that, it's going to be pointing here, one location before this first element of ArrayList. As soon as you perform has next, what it does, it gets you boolean value, true or false. So if you make a call to has next function of this string iterator object, it's actually going to check the memory address, whatever is next to it, which means this address, whether there is a value present or not. If there is a value present, then it's going to give you true. If there is no value present, then it's going to give you false. Now because we have a value present in it, which is Ankush, it's going to get us the result as true. Alright, as soon as it gets us the result true, it's going to enter into this while loop. As soon as it enters into this while loop, it's simply gonna execute this statement. Now what is this statement? This statement is next. So it has just checked whether element is present here or not. Still the pointer is at this position only, and when you make a call to the next function of this iterator, what it does, it actually goes to the next position, which is nothing but this position. And here whatever element is there, it's going to retrieve that, and it's going to retrieve this element Ankush string object. So that's what it's going to get, and here you are printing. So again it's going to go here, and again it's going to check whether next element is there or not. Yeah, so it's going to check here whether next element is there or not, because Gaurav is there, so it's going to retrieve true. So it's again come here, and again the pointer is going to shift to next memory location, and again it's going to give you Gaurav string object. That's what you are printing. So it's going to go likewise, and in the end when it's going to reach over here, let's say it's printing and the pointer is here, it has already printed Ankush, Gaurav, gone to and software. Now when you are going to come over here, it's going to check for next element, whether next element is present or not, because there is no next element present. So here it's actually going to return you false. As soon as it's going to return you false, it's going to terminate this loop and it's going to come out of it. That's how this whole iterator concept works. Have you got it? Great, guys. So this is how it has actually printed this whole list, whatever we have added here. Now the way I've shown you this iterator concept working for this string ArrayList, same way you can make use of for integer or for country. Alright, so let me show you that very quickly. In order to make use of this iterator concept for integer, what you have to do, iterator, and here you have to specify what is that type what you have stored in this ArrayList, integer, right? So here you have specified that, and then integer, let's say we gave it a name integer itr, and then you have to write the while loop. That's all about it. Same thing, you have to use this to check the next element is present or not, and then you are simply going to get that, and then you will print it out, a dot int value. So this is how you print the value whatever is stored in this integer object. You have to make a call to its int value function. The way we have used iterator over here, same way you can make use of iterator here for the country. So here I'll make a very small change. So this is this array country, and here it's country. Cool. Now whenever you're going to perform next on this, it's going to get you the country object. Once you get the country object, then you are simply going to make a call to its name property or population property in order to display that. Let's say you want to display name and population both here. So what you will do, will make a call to both like this. So here it's going to display name first and then space and then population. So if I run this is how it's gonna work. See, first it printed all the elements of ArrayList, then it printed all the elements of integer, whatever we stored, and then it printed all the elements of the country ArrayList. The important point what you have to understand is whenever you use iterator on ArrayList, that time it displays things, it retrieves things in the order you have stored the things. So it's going to maintain the order of the ArrayList. So you stored Ankush first, then Gaurav, then Gontu, then software. So that's how it actually retrieved things, in the same order. It's not that first it's going to retrieve you this element and this and then that. No, it's going to maintain the order in which you created the ArrayList. So same thing is applicable here for integer, same thing is applicable for a user defined type country, same thing is going to be applicable for any non-primitive type ArrayList what you are going to use. Alright, so what's next? Next is, what if you want to retrieve an element what is stored in ArrayList on a specific index? Yeah, so how you can achieve that? That's also very simple. You write the ArrayList of that type, ArrayList object of that type dot get. So get function, if you call on this ArrayList, it's going to ask you which object you want to retrieve. Let's say we have specified here 2. So what it's going to do, it's going to go to the second position of this ArrayList and it's going to retrieve that object. So what is stored at second position, guys? This is stored at 0 position, this is stored at first position, and this is stored at second position. So if you print this element, it's going to get you this Gontu 0 1 second. So here it's going to get you what? String object, of course. Let's say this is what you get. Yeah, so here it's going to get you the string object. So if you display this a1.toString, it's going to print out Gontu, which is nothing but this. So let me very quickly show you this working. See, first it displayed the complete list, Ankush, Gaurav, Gontu, software, and then it printed Gontu because of this statement. So it basically retrieved the element string object which is stored at second position. So the way I've used it for second position, you may go on using for any appropriate position. You may make a call to get position to retrieve 0th position, first position, second position, or third position, right? So this is how it works. This is the get function to retrieve an element which is stored at a specific index, at a specific position. Alright, now what if you want to remove any element which is stored in ArrayList? The way to do that is you write the ArrayList object dot remove. So this is going to actually do that. Here you are going to specify which position you want to basically remove from ArrayList. Let's say we specify 0 1 2. Let's say we specify second position. So if we make a call to this remove function, what's going to happen? It's simply going to remove this Gontu from ArrayList. So here you have stored 4 elements, 4 string objects in ArrayList. As soon as it executes this statement, it's going to actually delete this. And how many elements are going to remain in the ArrayList in that case? Only 3 elements, right? Because it has just now deleted Gontu because of this. So after this, if you will use iterator to display the elements of array list, what it's going to display, it's only going to display 3 elements, because gone to it's going to delete from the list because of this remove function. Now here, one important point you have to understand how this works behind the scenes. The way it works behind the scenes is also very simple. So this is the memory. It stored Ankush here, then Gaurav here, and then gone to here, and then software here. Alright, now as soon as you make JDK execute this statement, what it's going to do, it's actually going to the second position, which is nothing but this, and it's going to delete this. Now what you have to understand is when it deletes any specific element which is stored in the array list, what it does, it deletes that, and then it shifts all the elements what are stored at its right position by 1. So it's going to delete this, and it's going to shift this to its left by 1. And if there would have been some elements stored here also, it would have been shifted one element, it would have shifted that element also to its left by 1. So whenever you delete any element, you remove any element from the array list, it's actually going to shift all the elements to the right side of that by 1 in order to fill up that gap, right? This is what you have to understand. So here it's going to shift software here, and it's going to delete this. So this is how it works. So now at 0th position you have Ankush, at 1st position you have Gaurav, and at 2nd position you have software. So earlier you were having gone to at 2nd position, but once you made a call to this remove function, this software got shifted by 1, and now at 2nd position you have got software. So this is how it works. So here, after this, if you try to execute this, if you try to retrieve the element 2, what value it's going to give you? Well, software. So earlier it was stored at 3rd position, but once you deleted gone to, it actually was shifted to the 2nd position, and that's what it's going to display. See, first it displayed all the elements till this point, and then it printed 2nd position where you stored gone to, and then you removed that element gone to 2nd position, and then the elements to the right side of that got shifted by 1 to their left, and because of that, now when you are retrieving the value 2, retrieving the value which is stored at 2nd position, it's going to get you this software, what was previously stored at 3rd position. Now this is very important to understand, guys. What if you have 1 billion string elements stored in this array list? So on up to 1 billion number. Now it has got element, so you have filled up all 1 billion element, and you give instruction to delete the element what is stored at 2nd, this 1st position. Now what it's going to do, it's going to delete that, and it's going to move this element here, it's going to move this element here, this element here. So it's going to shift all the elements right to this by 1. Now what point you have to observe here is, in order to delete something, it not just has to delete that element, but it has to shift all the elements by 1. Now that is a lot of work. If it has to shift just 1 or 2 elements, it's all fine, but it has to shift all the elements. Now how many elements are there to the right hand side of it? Around 1 billion elements. Yeah, so it's going to shift all the elements by 1. So in order to delete something, it has to perform a lot of shift operation, and that's actually going to take a lot of time to happen. So this delete operation is actually very costly in the sense it has to delete not just that element, but it has to shift all the elements also by 1, and that takes a lot of time. So if it takes 1 second to delete this, then it's going to take the time also to shift all the elements. And let's say in order to shift one element to its left hand side takes 1 second. Now assume you may understand how much time it's going to take extra to shift all elements. So 1 second for one shift. So for around 1 billion shifts, how many seconds extra? So many seconds extra. So that's the reason sometimes developers don't want to make use of ArrayList for this reason's sake, because if they are going to remove any element, then that's going to take a lot of time to delete that specific element from that ArrayList. Right? That's the reason they sometimes call an ArrayList performance bit slower, because of this point, because of these shift things. All right, so if this is the drawback of an ArrayList, that whenever you are going to delete any element, it's going to take a lot of time to delete that, then what else you can make use of instead of an ArrayList? Well, we're gonna see that in just a couple of moments after we finish up ArrayList. So once we finish up ArrayList, we're gonna look at one more collection with the name linked list. So that's going to eliminate this problem, which we are going to see later on. But for now, I just want to understand this big problem, that whenever you use ArrayList and you want to delete some element, then actually that's that's actually comparatively slower because of all that shift operation what it has to perform in addition to delete. All right, I hope you have understood this concept. Now the way you have used remove function here, same way you can use a remove function here also for array integer. Same functions are available here also. So here you specify the type. If you want to retrieve some specific element from this array list of type integer, you have to specify that type. It's going to give you that. Same thing is available here also. If you want to remove an element from this array list country type, you have to simply make use of remove function. You have to specify which object you want it to remove. And if you want to retrieve any specific element which is stored at a specific index or location, you have to specify that location. It's going to give you that object. So this is how it works. So we just looked at the array list. Why we used array list? Because of the capacity problem what we faced in array. You can use array list with any non-primitive data type available, like string, like integer, like any other user defined type. Alright, any type, long, boolean, anything. To store elements in the array list, you have to use add function. In order to iterate through the complete list, you have to make use of the iterator concept. When you are using iterator for a string array list, you have to write here string. If you are making use of iterator for an array list of type integer, you have to write integer. If you are making use of an iterator for a type country array list, then you have to write here country. And then this is the way iterator is going to iterate through the complete list. If you want to retrieve any element of that list stored at a specific location or index, you have to do that using get function of it. You can remove any element by making use of remove on that array list. Same is available for integer. Same is available in case of user defined type or any other non-primitive type. So this is very easy, guys. I just want you to understand the simplicity of this concept. All right. Now here we have so far been talking about how to make use of the array list in order to store elements, in order to display the elements in the order we have stored, then how to get that specific element, how to remove a specific element. Now here what I want you to concentrate on an important point. The important point is iterator is going to display all the elements it is going to help you display all the elements in the specific order, the order which you stored things in that array list. But it's not going to arrange things in ascending order or descending order. What if you want to arrange, what if you want to display the contents of array list string in the ascending order? How you are going to do that? So here, what ascending order means? Ascending order means the dictionary order, the lexicological order. So here Ankush comes first, then Gaurav, then Gontu, then software. So it's going to come on top, and then it's going to choose Gaurav or Gontu. Yeah. So here it's going to compare G with G, O with O, R with N. Now if we see, N comes first, then R. So it's going to be treated at second position after Ankush. And then Gaurav is going to come at third, and then software is going to come at fourth position. So this is how order, dictionary order works. This is how lexicological order works. So what if we want to display the contents of this string array list in the lexicological order or dictionary order? How we can do that? Well, there's a very easy way to actually achieve that. And what is that way? There's a class available in Java known with the name collections. What you have to do is you have to make a call to one of its functions known as sort. If you make a call to its function sort on this collections class and you pass that array list to that, what it's going to do? It is simply going to rearrange the elements of this list in the lexicological order. So if this is the memory, you stored Ankush here, then you stored Gaurav here, then Gontu here, and then software here. Once you make a call to this function collections.sort, you make a call to sort function of collections and you passed array list to that, it's going to rearrange this whole list in a new order, and that is which order? Lexicological order, dictionary order. Or it's going to store Ankush here, then it's going to store Gontu here, it's going to store Gaurav at this position, and software is going to be remained at this position only. So whatever is lexicological order, it's going to rearrange. Now if you try to make a call to get function at second position, which value it's going to give you? Definitely this new position of Gaurav, which is nothing but second position. So at second position you will get Gaurav, at first position you will get Ankush. So it's basically going to rearrange the list for you. So that's what is the purpose of collections.sort function on this array list. Now in case of numbers, integers, if you are going to make a call to, what's going to happen? Let's see. Collections.sort. Here if I pass integer array list, what's going to happen? It's going to sort in ascending order. In case of string, it's going to display things in lexicological order. In case of integer, it's going to display things in ascending order. Alright, which is nothing but first it's going to display 1. It's going to arrange this whole array integer array list in the new order, where this object is going to be repositioned at 0th position. This is going to be repositioned at first index. This is going to be repositioned at second index, and this is going to be repositioned at third index. So after this line, if you want to retrieve any element out of it, it's going to be printed in that new order, whatever is going to save. Make sense? Now how about this? We know for string we can Java can arrange things in lexicological order. All right, for integer, if you want to display things in ascending order, it can display as per the value of that integer. Right, now in case of country, what order is going to give you? If you are actually going to make a call to collections.sort and you are going to pass that array country to that, what order it's going to give you? Well, you cannot comment on that. Why? Because in case of string, it was clear that it can use the value of that, and here it can use the value of this integer, but here you have two values in it instead of one. You have int 10 and you have India. Now if it orders things in lexicological order, then it's going to arrange this whole array list of country in a different order, and if it orders this whole array list of country according to the population, then it's going to display things in a different way, right? Now which order you want, that depends on you. Are you getting my point? If you want it to collections.sort to order this array list as per this population, then you specify that, hey, I want it to be sorted based on the population. If you want it to be sorted based on this name, then you specify there to collections.sort method that you want it to order things based on this. Now what is the way to do that? The way to do that, guys, is very simple. The way to do that is you have to write something very special to this, known with the name comparator. Now what is that? Let me talk about that. So here you basically have two options. You can instruct Java to sort this using either population or using name, right? So here let me write a class with the name population comparator. What is this? I'll explain you in just a moment. Implements comparator, and here you have to pass the type. What is that type? Country. Guys, please be attentive. Okay, you'll be able to understand it in just a couple of moments, but I want you to be very, very attentive here to understand this fully. Okay, don't feel like something big has come up which you cannot understand. No, there's nothing like that. It's very easy. It's just that you are seeing it very first time, so you may find it little difficult, and I haven't explained you anything about comparator so far. I'm going to explain you gradually, so just keep up your pace with me. All right, so what you have to do, you have to create a class. You can give any name to that. I've given population comparator, which implements an interface known with the name comparator, and to that you have to use country in less than or equal to, because you are developing the comparator class for country type. So this class you are actually going to make use of here in order to tell collections.sort method that you want actually this array list of country to be sorted based on the population and not based on this. So that is what you have to specify here. How you're going to specify here? You are actually going to do like this: population comparator. So what you are basically going to do here, you are going to make a call to sort function of collections class. You're going to pass array country, but here this is going to be confused, on what basis it's going to sort this, on what basis it's going to arrange this array list. All right, for string it was easy, it's going to just check the value. For integer it was easy, it had to check the value and it's going to sort. But in case of country, there are two things you have stored: population as well as name. So on what basis it has to sort, that's what we are conveying here it explicitly, and this is the way to do that. You have to write here the class name, based on that it should actually arrange things in the order. Now here we have written population comparator. Same way you are going to make use of the name comparator, which I'm going to show you in just a couple of moments. But before that, let's complete this. So in this population comparator, what you have to do basically, so this is the interface comparator. Okay, this is the interface available in Java which you have to implement. Now, as we learned things about interface has got only method names without body, right? And why it is crying? Because it says there is a method which is present in comparator which you haven't implemented yet. So here it's crying only for that reason's sake. So here I'm actually forced to implement that method which is present in comparator, which I haven't implemented so far. Now what is that method? There's a shortcut to know. Well, first way is to look at this comparator class and know what all methods are there which you have to implement. Second way is it's showing red color over here, right? Now what you have to do, you have to just click here, and here there's a line you would get add unimplemented methods. So once you click on it, it's going to automatically implement all the methods what are present in this comparator interface. So once I do that, I get this. So there's only one method in this comparator which hasn't got the body inside it, so I have to just implement that. So it has automatically done that for me. Right? So far I showed you that you have to look at comparator interface, and whatever method is there you have to implement. You can always do that, but in Eclipse IDE there is a shortcut available that if you click here, it's actually going to implement that automatically for you. Alright, now what is this code? Guys, be very, very attentive. So here the point is, when collections.sort method you are going to call array country, it's basically going to analyze all these 4 objects of it. It's going to compare one object with another object in order to find out which object comes first and which object comes second. And it's going to do that for all, and then it's going to arrange the whole stuff. Now when you say that it has to be arranged using population comparator, what exactly is going to happen behind the scenes? It's actually collections.sort is actually going to go to this population comparator class, and then it's going to make a call to this function compare, whatever we have included here, and here it's going to pass those 2 objects, O1 and O2. Let me call this as C1, CN1, country object 1 and country object 2. Alright, so whenever it's actually comparing 2 objects to know which object comes first and second, so it's going to pass those 2 objects here to this population comparator compare function. It's going to pass those 2 objects. Now what you want here, you basically have to write here logic about how it has to be compared. So what I'm going to write, please be attentive guys, cn1 dot population, cn object population if is equal to cn2 dot population. In that case I want it to return 0. You are just going to understand what is the meaning of this return value. Just keep up the pace. Okay, don't stop here guys, keep going with me, you'll be able to understand every bit of it. If this value is greater than the value of c1 object, cn2 population, cn1. So if this is greater than this, then return 1. If cn1 dot population is less than cn2 dot population, then return -1. Now what does it mean? Else if else. right guys? So this is how you use if, else, if, else, right? So here you're saying whenever it's comparing elements of this array list, it has to compare two objects always, right? It's going to make a call to the compare function of this population comparator class. It's going to go here, it's going to make a call to that, and here this method is supposed to be returning an int value 0, 1 or -1. Now when you return 0, it means both objects it should consider as equal. It doesn't matter which object comes first and which object comes second. It's going to consider them equal. This collections.sort is going to consider both objects as equal. If population comparator, compare function is going to return 1, then what it means? It means collections.sort is going to consider first object bigger than second object. And if you return -1 here, what that means? It means collections.sort is going to understand that first object is actually lesser than second object. That's how it's going to arrange things. So it's just about arranging things in ascending order, and how it's going to do that. This is the simplest way how it performs. Let me show you this with the help of this diagram. So here when you make a call to collections.sort, what it's going to do, it's going to pick first these two elements, right? And it's going to make a call to compare function of this. In the compare function, what's there? First object is India, right? This object's one, and then second object is America, CN2. And here inside compare function, what you have written if CN1 equals to CN2, CN1's population is equal to CN2 population, which is definitely not the case because 10 is greater than 7. In else if, what you have written, if CN1 is greater than CN2 population, right, then what you have to return 1. So in this case 10 is greater than 7, so what it's going to do, it's actually going to return 1. As soon as it finds 1, what it's going to do, it's going to understand that India is actually bigger than America, so it's going to consider India at this position and America at second position, and then it's going to compare America and Bangladesh, and then it's going to compare Bangladesh and China. It's going to compare all the objects with each other, and then it's going to rearrange the whole array list of country with the help of this compare function what we have written inside population comparator. Now if we display now this list, what it's going to decide, the order in which it's going to display list is based on the population. So it's going to display first, it should actually display the population which is in the ascending order. So it's going to display 4 first, and then 7 first, and then 10, and then 12. So it's going to be displayed in this order. So shall we very quickly see that? So if I here make a call to this here only, and then I make use of an iterator to display the whole, it's going to actually display things according to this population comparator in the ascending order. Let's see if this does or not. It's giving me the error here. Index out of bounds exception, index at third position. Now why is it giving this? Let's check that. Oh, so here there's a problem that we are trying to access the element what is stored at third position, because we have removed second element 0, 1, 2. Once we remove the second element, this third element is going to be shifted to second element, right? And there is nothing here at third position, because here we are trying to access an element at third position. It's going to give you an error, index out of bounds. You remember this error? Whenever you try to access some position which is not existing, it's going to give you index out of bounds exception. And here it's going to give you index out of bounds exceptions on the array, right? So this is again a proof that ArrayList internally uses array only. So let me remove that. Let me show you this running. See what it has done. It has displayed 4 and then 7 and then 10 and then 12. It has rearranged this whole list in ascending order based on population comparator, based on what we have written in this compare. So when you return 0, it means it has to consider both objects as same. When we return 1, it means first object is more than second. When we return -1, it's going to consider second object is greater than first object. So it has done that. Now if I remove this and if I make a call to this, it's going to display things in the order I have here included things in this ArrayList country object. So first it's going to display India, then America, then Bangladesh, and then China. And once I use it, it's going to rearrange things in this ArrayList based on this population comparator in the ascending order. That's what it has done. Cool. So if I remove this, it's basically going to display in the order what I have gone with, the order in which I have the order which I use to insert elements in this ArrayList country object. If I use this, it's going to rearrange things. Now here we have written population comparator, which is going to tell collections.sort method, hey, kindly sort the elements of ArrayList country based on the population comparator method, which is nothing but this, means based on the population values. Now what if I want to basically sort this country object based on the name, not population? In that case, I have to write one more comparator for the name, right? So let me do that very quickly. Name comparator. Let me click on finish, and here also I have to follow the same strategy what I followed here. I have to implement comparator. Implements comparator interface. To that I have to pass country, because this name comparator we have written for country, user defined object, right? Now again I have to implement the compare function the way we have done here. So I'll very quickly click here to implement the method. See, it has done that. Now we have a cn1 and we have cn2, and here what we have to do, we have to simply write a logic which is going to return 0, 1 or -1 based using the name. So what we have to do here, we have to compare the characters what we have stored in the string, one by one, so that we can know what comes first and what comes second. So you have to write that whole logic here. Now one way is that you write the whole logic and then you return 0, 1 or -1 based on that logic. And second is you make use of one more facility which is provided in Java, which is about making call to the name function of main name property of that. So cn1 is having the name property. So what we are going to do, we will go here to the name comparator and we'll make a call to its name property, and then we have to use a function called as compare to, and here we have to write cn2 dot name. That's it. So what it's going to do, whenever we make a call to compare to function on any string object and we pass another string object to that, it's actually going to give you 0, 1 or -1 based on whether this object comes first or next, comes first or comes before or after this object based on lexicological order. So this is how it works. If I am not using this compare to function, then I have to write here complete logic myself in order to identify whether cn1 comes first or cn2 comes first by comparing every character of name property of this and name property of this to understand whether I have to return 0, 1 or -1. That's a bit tough to do that, and there's a direct function available compared to achieve that, so I'm making use of that direct function. So once this name comparator is ready, I can actually make use of the same here. Instead of this population comparator, I can use name comparator. And once I use that, what it's going to do now, it's going to go to the name comparator compare function. It's going to pass two objects, in order to sort this whole list. Always it's going to pass two objects, and depending upon what results it gets by passing many times two objects of this list, it's going to rearrange this whole list. So it's going to make a call to this, and it's going to be compared. Name of this and name of this is going to be compared, and accordingly 0, 1 or -1 it's going to return. This comparative function is going to return, and accordingly it's going to sort out this whole user defined array list, that is country, and it's going to display. So now we are doing things using name, right? It's going to compare name, that is string. So now what it should display, it should first display which one? It should first display America, because A comes first. So lexicologically, dictionary order wise, America comes first, and then Bangladesh, because B comes next, and then it's going to display C, and then it's going to display I, that is India. So it's going to display A, America first, then Bangladesh, and then China, and then India. Let's see if this works or not. See here, that's how it is working. America, Bangladesh, China, and India. Now the important point what you have to understand is, in case of string, when you use collections dot sort, it automatically sorts the whole array list of string based on dictionary order or lexicological order. When you make a call to collections dot sort on an array of type on an array list of type integer, it's going to see the value and it's going to arrange things in the ascending order based on the values of that. But when you do things with any user defined type and you want to make use of sort functionality there, it's mandatory for you to have the comparator class available. So based on what property of that user defined object you want to sort, you have to explicitly create in your project. You want to sort using name property, then you have to use name comparator. If you have to sort based on population, then you have to use population comparator. It's going to simply make use of the compare function what you have included here. Inside compare function, you have to write a logic which is going to return 0, 1 or -1. So these values simply tells sort function whether first object is equal to, bigger than, or lesser than the second object, and accordingly it's going to sort out the whole list. And here also you have to write that whole logic which is going to return 0, 1 or -1, because that logic is going to take some time for me to write. So here I'm using its function compare to. So you can make a call to compare to function which is available for every string object, which is going to basically return you 0, 1 or -1, and accordingly it's going to sort out the whole list. Now here an important point what you have to understand is, for this array country array list object, you want it to simply sort, and when you use collections.sort, you use name comparator or population comparator. So you explicitly told sort that, hey, I want it to be sorted based on name comparator or population comparator. Now what if you don't want to use that? What if you don't want to basically use any comparator here? You want it to use by default population or by default name. How to do that? The way to do that is, whatever default way you want to follow when you don't want to use comparator class, then in that case you have to go to the country user defined object, and here you have to do one thing. You have to implement something called as comparable, and here also you have to pass country. And because you are implementing an interface over here, so you can implement its method, and what you are going to do here, same logic you have to write here. So now here you can specify you want to do it based on the name, or you want to sort it based on the populations. You have to write. So if I write here based on this population, what I have to do, I have to copy the contents of it. I have to simply go there to this country. I have to simply specify here this. Now here this O, so this is basically CN2. Alright, now what is this CN1? This is this object. I hope you are able to understand this, right? If not, you have always one-on-one conversation with me, right, after the session. So you have to ask, clarify every single doubt that you might be having here with me. Alright, so what's going to happen here? Whenever you make a call to sort function without applying the comparator class, then what it does, it basically every time is going to make a call to this function to understand whether first object is bigger than second object. So it's going to make a call to compare to function on this object first. So it's going to make a call to compare function, compare to function on this object. It's going to come over here, and here it's going to pass the second object to that, which is this object. So on India object, it's going to make a call to compare to function, and it's going to pass America object to that. And here inside it, we are simply checking which object is bigger, India object, which is nothing but this object, or this object, America object. And accordingly, it's going to return 0, 1, and -1. So it's going to make a call to compare to function for all the combinations here, and accordingly, it's going to rearrange things. Now, the point which you have to understand is, if you do not want to specify comparator, means you don't want to explicitly tell sort function whether you want to sort this based on this or this, then in that case you have to implement comparable interface in the country class itself, in the user defined class only, and there you have to write the whole logic for the same, and it's going to use by default that. If you are not using this comparable in this user defined type, then it's mandatory for you to specify the comparator, because we have we have specified the default way, comparable way in this class itself. So it's actually allowing us to use collections.sort here, because it's going to sort now based on the population. And what population code I've written here, this is the code. So if I run this, it's going to display things based on this default approach. See, Bangladesh, then America, then India, and then China. Based on population, it has sorted. So this is the default way. Now if I remove this default way from here, then in that case it's not going to allow me to write this. It's showing me the error. It says either provide me the default way so that I can sort this whole array list of user defined object, or tell me based on what comparator I have to solve. So here, when we have not provided default way, then it's mandatory for us to write that comparator argument to that, otherwise it's going to give you red color error. So here you have to write new population comparator, or you have to choose name comparator. The point which you have understood is, in case of a user defined type, if you want to make use of sort functionality, then you have to write comparator so that you can explicitly tell on what property, based on which property it has to sort the whole list. And if you don't want to make use of the comparator class, then you have to provide the default way of comparing two objects that you can do using comparable interface implementation this way. So here you wrote things to be arranged using population. If you want, you can copy this whole logic to tell that by default it has to arrange things based on the name. This country CN1. So now it's going to arrange the whole list based on the default way, which is nothing but the names. So it's going to display first America, then Bangladesh, and then China, and then India. This is very simple. See, America, Bangladesh, China, and then India. So what all things you learned today? You learned the concept of an array list. You learned how to make use of the array list for string, for integer, for a user defined type. The same way, the way I showed you things for these three types, you can go on creating array list for any other non-primitive data type available. In case of string, if you want to make use of sort, then it's going to directly allow you to do that. Now the point that you have to understand here is, in case of the user defined object, you had to basically use comparable interface. You have written here the logic which it is going to use to sort the whole list. Now here, when you say you are trying to sort the array list for string, right? Now here, what point you have to understand is, every string object, every string class, every string object basically has got that comparable, that default method available. The way you have implemented this compare to function in this, right, the way you have implemented in this country user defined object, same way Java people have implemented this compare to function inside this string class. So that's how it doesn't cry here, and it just uses that compare to function to sort this whole string array list in the lexicological order. Same way in case of integer class, that compare to function is written. So when you use sort function on that, it actually doesn't cry. It actually allows you to sort that based on that compare to function what is written inside this integer class. So here you are writing country object. If you want it to sort things, then you have to write the compare to object inside it, and that's what you did. You wrote compare to object function inside it to compare things. So you can compare based on name or based on population, based on anything. So that's how it works. So you are using comparable interface so as to provide the default way of sorting a user defined object. And if you are using any primitive type which is available already in Java, then the point which you have to understand is, this type implements compare to function, this string implements compare to function, which it uses to sort the whole list, string list, string array list, integer array list. Cool. And if you don't want to provide the default way, then you can use the comparator classes that you have written. The way to write comparator classes to implement the comparator interface and provide the type for what you are writing the comparator, and then simply compare function you have to implement, and inside it what logic you have to write. So the logic which you want to make use of to compare two things, same logic you have to write there. Now what if you have the default way written? It means you have already implemented comparable interface in this country user defined object, and also you have name comparator and population comparator, and the point is, you don't want to go with default way, you want to go with the comparator way. Explicit way of telling Java that, hey, sort it out, sort this whole list based on this logic or this logic. Then what is the way to do that? Nothing much. You write things like this way. So here, whenever you are going to specify the comparator, Java is not going to use the default way, it's actually going to use the comparator way, whatever you have provided. So here, if you look at this, it's using name way to compare two objects of this country. So it's going to sort based on the name, the whole ArrayList country object. But when you have specified population comparator here, it's going to simply override that. Means it's not going to use this default way, it's actually going to make use of this comparator way. So my suggestion is, see, it has done things using population way. So my suggestion is, whenever you store any user defined type in ArrayList, then write there some default way. So when you are not going to make use of any comparator, then collections.sort is going to actually make use of that. But if you want to use any specific comparator, if you want to sort the list based on any specific property of that, then you used comparator. Cool. So this is how it works. The important point is, if you do not implement comparator comparable interface in this country object, in that case this line is not allowed. It's allowing you to write this way only because it is finding comparable interface in this country. If you are going to take this out from here, it actually is going to cry that it doesn't implement comparable interface. Yeah, I guess that's all we have for comparator and comparable interfaces. So here today, what all things you have learned how to create an array list for all non-primitive types, and then you looked at the collections class, and then you looked at the comparable and comparator interface concept. So this is all you have learned today. Alright, now what is next? Let's look at what we have written here in order to understand the array list, in order to finish up this array list topic fully, and then we are going to wind up today's session. Why array list we looked at? Because to eliminate capacity problem. This is the syntax of that problem, syntax of how to make use of an array list in your program. Properties: maintains insertion order and allows duplicate elements. What does it mean? It simply means if you have stored elements in this order, first Ankush, then Gaurav, then Gontu, and then software, and you make a call to iterator, then it's going to maintain that insertion order. That's what is this means, maintains insertion order. So the way you are going to put elements in that, using iterator you can retrieve in the same order. Allows duplicate elements means what? If you are going to store here 2 times Ankush string object, it's allowed. So if you are going to display the contents of it, it's going to display first Ankush object, then Ankush object, then Gaurav, then Gontu, then software. See, it has displayed first Ankush, which is nothing but this object, then Ankush, which is nothing but this object, then Gaurav, and then Gontu, and then finally software, and then it's going to execute rest piece of code, right? So here this is what it means, maintains insertion order, and this is what it means, allows duplicate elements. Yeah. Now allows random access very fast. This is an advantage of ArrayList. So what is this advantage? We talked about this advantage. So this is the memory. You have stored Ankush here at 0th position, Ankush at 1st position, Gaurav at 2nd position, Gontu at 3rd position, and software at 5th position, right? Now if I ask you, hey, please get me the element which is stored at 2nd position, then JDK knows where this 2nd position is. It will go here. It will directly go to that 2nd position, 0, 1 second. So this is the 2nd position. It's not going to look at this. 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 So whenever you specify the position, it's going to directly go to that position and it's going to get you the result which is stored there, Gaurav. So it's actually very fast in that way, right? Whenever you want to retrieve any element in the array list by specifying its index, then that's instantaneous. It's directly going to go to that location and it's going to fetch that value. It's going to provide that. That's what I've written there. See here. Allows random access, so very fast. So it can whichever position you are going to specify, it's going to go to that position directly and it's going to fetch that element. So we say that it's very fast. Now what is the disadvantage of this? The disadvantage of using an array list is the one that I talked about earlier. If you are going to remove any element, if you are going to remove any element from the array list, what it's going to do, it's going to shift. It's going to first delete that element. Let's say you want to delete Gaurav. It's going to delete Gaurav, and then it's going to shift all the elements right to this element by 1. So that's actually a very costly operation. So that's what I mean here by disadvantage. A lot of shifting needs to be done if an element is removed from an array list. So manipulation is very slow. So whenever you delete things, it's actually very slow. And then there is one more point I've written here: slower, as its capacity is increased by 50% from current upon getting filled up completely. Now what does it mean? Let's try to understand. Guys, I said that internally an array list is an array only. So whenever you write this statement, what it does behind the scenes, actually this is very important to understand, guys, so please be attentive. Whenever you write this syntax, what it does behind the scenes, it actually creates an array of type string having a capacity 10 always. So behind the scenes it actually creates an array having a capacity 10, 1 2 3 4 5 6 7 8 9 and 10. So it's always going to create a string array. So this line is actually equivalent to this new string 10. So this line is actually equivalent to this string. So behind the scenes it's going to actually consider 10 positions in the string array. But the advantage of it is, once you fill up this space by storing some element to it, then to this, then to this, then to this, once you are here, once you are done with storing all elements here and this list is fit, this list is actually full, and you try to store 11th element into it, what it does behind the scene, this array list, it actually checks the size. So what is the size? 10. So what it's going to do, it's actually going to add capacity to this, half the size, half of its current size. So what is the current size? 10. So what it's going to do, it's going to do this 10 divided by 5, 5. So it's going to add 5 more units to it, 1 2 3 4 and 5. So now 11th element it's going to add here, 12th element it's going to add here. So as soon as it reaches to the end, then again it checks the capacity. So what's the current capacity? 10 plus 5, 15. So it's going to do 5, and whatever result it's going to get, based on that, it's going to add additional capacity to that. So 16th element it's going to add there, then it will go on. So as you reach towards the end of the array list capacity, it's actually going to grow by 50% of its current size. Now every time it grows its capacity by 50%, what behind the scenes it does, it basically has to create that 50% space extra there, right? And it cannot do that directly. What it does basically, let's say this is the space, 10 elements, all right, and as soon as you want to store 11th element in that, what it does, it checks its capacity, divides it by 5, it divides it by 2, and then it add that capacity here. So what that means is, it's going to actually discard this current array. What it does, it creates a new string array having a capacity, this capacity plus 50% of this, means it's going to create one more string array of capacity 15, 10 this, and then half of this plus. So it's going to create an array of size 15 here, and then it's going to copy the contents of this array to this, and it's going to simply discard this. So it's going to first copy all the 10 positions of it, and then whatever you were trying to insert, 11th position, it's going to insert that, and it's going to delete that. So have you understood how it works behind the scenes, how ArrayList works behind the scene? ArrayList is simply an array of type string behind the scenes if you have created an ArrayList for string. In case of an integer, it's basically an array of type integer behind the scenes. How it works? When you write this first statement, it creates an array of that specific type, having a capacity 10. And once you are done with that capacity, once you fill all the elements, once you fill that array list fully, then it basically increases its size by 50% once you try to store one more element after you fill up its capacity. But in order to add that 50% capacity to that existing string, it has to perform that action. What it does, it creates a bigger array having that full capacity, current capacity plus 50% of that current capacity. It copies the elements from that existing array list, and then it adds new element, whatever you want it to store, and then it discards that fully. So this is kind of making it a bit slow, right? This is actually making a bit slow, right? Because once you try to insert element at 11th position, it has to first create that bigger array, and then it has to copy elements from first array to this array, then it has to insert 11th element at 11th position. So much of work to do. So this makes it little slow. So if you are storing element at 10th position, it has to just insert element at 10th position. But when you try to insert element at its 11th position, that time it has to perform this action. It has to create that bigger array, then copy the contents, and then including element at 11th position. So this whole thing makes it little slower, and that's what I've written over here. Slower as its capacity is increased by 50% from current upon getting filled up completely. Initial capacity 10. So whenever you create an array list of any specific type, then it behind the scenes creates an array of that specific type having a capacity 10, and then it goes on increasing its capacity when you fill up that array list fully, and it's going to grow by 50% every time you are filling up that fully. Alright, but you can always alter this initial capacity. So here, if you do not specify initial capacity, it's going to choose its initial capacity as 10. But what if you want to specify its initial capacity? Anyways, it's going to grow dynamically at runtime as in when you are going to add elements to it. But if you want to alter this initial capacity, say you want to set 100. So if you write here 100 to this, it's going to actually create an array of type string behind the scenes having capacity 100 initially only. And if you do not, then it's going to assume 10. So what's the advantage of specifying the capacity in the beginning itself? Let's say you are creating an array list and you are for sure that at least you are going to store 1000 elements in that. Then it's not wise to keep it at the default way, because it's going to create behind the scenes an array having capacity 10. Now when you are going to insert 11th, it's going to double. When you are going to then it's going to give you size of 15. When you will try to insert element at 16th position, it's again going to increase its size by 50%. So it will actually do a lot of work. But if you specify here initially only 1000, then at least till you are going to insert 1000 elements in it, it's not going to alter its capacity, it's not going to modify its capacity. So there's no problem you would face in terms of its performance. Right? So this is what I've written here. It is slower because once its capacity is filled, it's going to increase by 50%, but initial level only you can always change its capacity. And then we talked about this special case, right? Elements can be retrieved in ascending order by making use of a comparable or a comparator interface along with the collection class. So collections.sort is going to sort the array list. Alright, if you want to go with default way, then you have to use comparable interface in that object, user defined object. And in case of other non-user defined objects like string, like integer, like long, this comparable interface is already implemented, so that uses that default way. But if you do not want to go with default way, then you have to write a class separately, like name comparator, like population comparator, which is going to implement comparator interface. So you can pass that along with the array list of that type to this collections.sort, collections method sort, and it's going to sort the whole array list of that non-primitive type. So this is what is an array list all about. Guys, when I say Java collections, the only thing that you have to learn in this whole topic is array list. In the next session, you will observe that I'll very quickly cover, rest of the collections very quickly. It's only that you have to be very, very attentive while learning array list, means first topic of it, and rest all topics we are going to be covering very fast way, because whatever concepts you have learned in array list, same concepts are actually are applicable in all of these other collections what you are seeing right now. So today's session was a bit lengthy and a bit heavy in terms of the concepts which were involved here, but in order to learn rest of the collections, it's actually going to be a very easy task, very, very easy task. Now you go and have a break of 10 or 15 minutes, according to your schedule, and come for one-on-one conversation with me and discuss everything whatever I talked about today. Whatever doubts you have, clarify all of them. All right, and in the next session we are going to cover rest of the collections as well. In first session we covered only array list, and you will see in the next session we are going to cover all of these collections. So easy, so simple. So whatever practice you are going to perform today, you are going to whatever practice you are going to do today for array list, that's going to be very, very helpful for you to understand rest of the things. And this topic Java collections is very important, guys. So do not skip this topic, do not skip one-on-one conversation for this topic, do not skip practice for this topic. This is the most important topic. No Java interview is completed without questions on this topic. So just do this. It's very easy. It's only that you have to practice and you have to clarify all the doubts you might be having, which you might be having after going to today's session. All right. So with this, let's wind up today's session. Let's catch up in the next session. Before your next session, you have to come for one-on-one conversation. All right. So I'm waiting for you there. Thanks for joining me, guys. Have a wonderful day.